Hi guys, and welcome back to the show. For those of you who are joining in, this is the last segment of the show and we are doing grade 12 physical sciences. Guys, exams is around the corner. Make sure that you're posting your questions onto our Facebook page or our email listed below. Now, I see that you have a whole bunch of questions that you're flooding me with. We are going to do another show later this week, so we will try
another two, actually.
Another two, so before your exam. So we will try and help you out. But for now, let's see what Tracy has in store for this last segment.
And guys, you know what? Somebody will try answer your questions on the Facebook page and also help each other. Seriously, the best way to learn why you think your teachers know so much, why my kids think I know so much, is because I do it all the time. So I teach this all the time, and the more you do it, the better you get at it. So help each other, teach each other, and I'm sure somebody will tell you if you get it wrong. But we are trying to help you on the Facebook page as well. So please just stay tuned. And I know Atik was saying to me that there's some of you have asked questions about concentration and those sort of things. We're going to hit that now. Okay, grade 11 stuff. Yay! It's actually one of my favorite things. So sodium thiosulfate, as I got corrected earlier today, okay, not thiosulfate, Na2SO3, was prepared by dissolving, okay, so we got a solution, 62.5 grams of the sodium thiosulfate crystals in distilled water in a volumetric flask of 250 centimeters cubed. Great. 10 centimeters cubed of this solution reacts with 20 centimeters cubed of the dilute hydrochloric acid. The balanced equation for the reaction is: calculate the mass of sulfur formed that will form if the sodium thiosulfate is the limiting reactant. Now, what that means for us is, first of all, the HCl is irrelevant. The fact that it reacted with 20 centimeters cubed of HCl is irrelevant. It doesn't matter. All that matters is the sodium thiosulfate, okay? It is the limiting reactant. So that determines how much sulfur we get. That means I need to know how much of this reacted. Now, I've got two volumes for the sodium thiosulfate. I've got the original solution, and then they tell me only 10 centimeters cubed of it worked. So I have to first work out how many moles of sodium thiosulfate was used, because that will tell me how much sulfur we get. Okay, how do we do that? Well, I'm going to use concentration. So, I don't think this is no, there we go, we're just going to do it here. So, first thing I'm going to do is, this thing doesn't like me. So I had 62.5 grams of the sodium thiosulfate in a 250 centimeter cubed container. Now remember, we can't work in centimeters cubed. Concentration is moles per decimeter cubed. So to get centimeters cubed to decimeters cubed, we divide by 1,000. Okay, now how do I remember that? Because this is quite an easy one. 1 centimeter cubed is 1 milliliter. 1 decimeter cubed is 1 liter. Easy, easy. And you hopefully know there's 1,000 milliliters in a liter. So, using the original information, okay, why is it doing that? So, let's use my finger. Okay, concentration is number of moles over volume. So my concentration is what I'm looking for. But I don't have number of moles. So now we remember, well, number of moles is mass over molar mass, and somewhere in the back of your minds, and it isn't on your information sheet, you remember that you can combine those. That says concentration is mass over molar mass times volume. So we go, okay, this is fine. I have mass, I have volume, I don't have molar mass. Okay, that means I have to work out molar mass. Okay, so I'm going to do it here, the molar mass of sodium thiosulfate. You need to go look on your periodic table as to what the mass of sodium, sulfur, and oxygen is. Like I said, I've been doing this for a while. So I know sodium is 23 and there's 2 of them. Sulfur is 16 and there's 2. Sulfur's not 16, sulfur's 32. 32. Oxygen is 16 and there's 3. So, now calculators, 2 times 23 plus 2 times 32 plus 3 times 16 And let's take it off scientific notation mode because that's silly. 158 grams per mole. Great. So concentration, which is mass, molar mass over volume, means I'm going to have 62,50 divided by 158 times 0,25. Okay, because we knew what the value was, so let's just see what that gives me. So 62.5 divided by 158 times 0.25. 1,58. Okay. Now, that's the concentration of the sodium thiosulfate solution that I made right at the beginning. But I didn't use all of this. They only used 10 centimeters cubed of this solution. And what I need is to know how many moles that relates to. So, number of moles is concentration times volume. So that means I'm going to do 1,58, and remember the volume was 10 centimeters cubed, so I'm going to divide by 1,000. No, that's just, oh geez, that's just horrific. There we go, it's not minus. Okay, so 10 divided by 1,000 is 0,01. This gives us horrible numbers, but that's okay, because watch what happens. So 1.58 times by 0.01 gives me 0, and I'm going to keep all those numbers, okay? I'm not going to round this one off. 0,0158 moles. But why is that important? Because, now watch here. If I go back to my question. 1 mole, oh wow. I have a randomly big long line for any. Okay, be nice. Here we go. Yes. Okay, I'm sorry about the flashing. I don't know what I'm doing. I do know what I'm doing. I know what this is doing. Okay, so 1. If you look bad, it'd be great. My kids tell me I pull funny faces when my technology doesn't play with me, which is true. 1 mole gives me 1 mole. It's a 1-to-1 relationship. That's very, very important. So that means, because I know how many moles of Na2S2O3 I used, I know how many moles of sulfur I created, because they told me that it's the limiting reactant. Sometimes they mean, in fact, the next question we're going to do is you have to rely on this. They mean, and they don't tell you what the limiting reactant is. You have to work it out first. Okay, but I promise you, unfortunately, this is one of those things you're going to get. So now watch what I'm going to do. The number of moles of sulfur is going to be 0,0158 times 1/1. That's the mole ratio. Okay, I have to put that in there. But that's not what they wanted. They wanted mass. So mass is number of moles times molar mass. Okay, and we know the mass of sulfur is 32. So I'm just going to times that by 32. And this one I'm going to round off, so it's 0,51. Let me just check with my answers as well that when I did it, 1 grams. It's tiny. It's a little bit. But I expected that. If I got an answer here with, like, say, 10 grams or 30 grams or something silly, I would re-look at it because, first of all, I only started with 62.5 grams of the sodium thiosulfate, which isn't even half a mole. And then out of that, I only used a very, very small portion of it. So I know I'm going to get very little sulfur at the end. And can you hear the groans, Atik? They're all like, oh, I hate this section. Grade 12s, I know you hate it, okay? But they can give you 3 questions easily with calculations in, one of which is your equilibrium. So you really need to get this, okay? Now the next one, acids and bases.
Tracy,
yes.
Before you go on,
yes.
Is there something I'm missing? I'm picking up that you're called Miss Fearless.
I am.
Is that a nickname for you?
No,
from
that's
your students?
that's my surname.
Oh, okay.
So maybe it's kids I teach who are going Miss Fearless. You never know. Because I know some of them were like, we want a shout out. And I said, well, tell me on the Facebook page that you're watching. Then, well, yes.
Okay.
It's maybe also because they know I'm a teacher. So, yes, that's not a nickname.
Okay.
It's really my surname.
I did not know that.
No, it is. It had many variations, needless to say. Like fearless, apparently. Moving on. So, getting to essence of bases. When I got sent this question to say I was going to do it this afternoon, I was like, oh, that's not it. And they went, ooh. Okay, maybe not so much, eh? This is not a nice question, okay? So I need you to work through it. The first part of it, part A, is grade 11 work. Part B is your grade 12 work, okay? Now they say to you, during an experiment, 50 decimeters cubed of a 0.1 mole per decimeter cubed hydrochloric acid, so that's that part, is added to 80 decimeters cubed of sodium carbonate, hydrogen carbonate, of concentration 0.25 moles. Great. The balanced equation for the reaction is, yes, it's balanced, bonus. Calculate the concentration of the hydroxide ions in the solution. And I went, hang on. My first protocol when I think of an acid-base reaction is to try and use the equation we learned last year, okay, where you did this, Na over Nb equals CaVa, okay? But then I went back to the information I was given, and I went, well, that doesn't make any sense because they gave me volume and concentration of both the acid and the base. Okay, this could be a problem, but they asked an interesting question. They said, calculate the hydroxide ions left. That means that the HCl must be my limiting reactant. That means I must have more NaHCO3 than I need. I need to know how much is left over, okay? Because the hydroxide ions have to come from the base. So, now I go back here and I say, fine, let's work out, where did you go? There we go. There we go. Okay, so let's ignore this because that's not important right now. Okay. Let's work out the concentration. No, I've got the concentration, I'm lying. Let's work out the number of moles, let's start with the HCl, of the HCl, which is going to be the concentration of the HCl times its volume. The HCl had a concentration of, where is it? They told me, no, they did. Where did I put it? See, there it is. Of 0.5 and a volume of, no, that's the other way around. 0.1 and the volume was 0.5. Okay, let's just check. There we go. Okay, so that means that if we do this quickly, 0.1, I'm just going to want to run out of time. Okay, so we've got 0.05 moles of HCl, not a problem. Number of moles of sodium hydrogen carbonate, concentration times volume. Here my concentration was 0.25. My volume was 0.8. So 0.25 times 0.8, 0.2. Now watch here. I have significantly more sodium hydrogen carbonate than HCl. It's a one-to-one relationship. You saw that from the reaction. So in order to use up all the HCl, I only need 0.05 moles of sodium hydrogen carbonate. So now, I don't know why it's doing that. Now watch where I'm going with this. The number of moles of sodium hydrogen carbonate left. How much is left over? Well, I started with 0.2. I used 0.05 because that's how much HCl I had, which then gives me 0.15 moles. This is similar to what we do in equilibrium. Okay, so we all happy with that? Now comes the fun part. They wanted concentration. Okay, concentration is number of moles over volume. Number of moles, not an issue. We've just worked that out. What's the volume? Trick. So we go back to the top. There we go. We're going to do it that way. We go to the back. Go back to the top. I had 50 centimeters cubed of the HCl. Sorry, 0.5 and 0.8. All of that volume got put together. All still in the same container. My volume is those two added together. So when I go back down here, I figured out how to use this. Shh, don't tell anyone. I need to add those together. This is the trick. So in other words, I'm going to have 0.15 divided by 1.3. Oops. So that gives me 0.12. Okay, let's make it 0.12. And now you're going, but Tracy, you haven't answered the question. I know we haven't. This is the fun part. They wanted the concentration of the OH minus ions. This is a little bit of a trick question here because we had sodium, hydrogen, carbonate. Because of that one hydrogen, it's only going to make one OH minus ion. So that means the concentration of the OH minus is equal to the concentration of the HCO3 that's left. So it's 0.12. Okay, that was the trick. There is no shortcut to this question. None whatsoever, I'm afraid. Okay, and in fact, the very next question relies on this answer because now they ask you to calculate the pH, and I'm going to have to go really quickly. You've got the OH, okay? Remember, pH is the negative log of the H3O plus concentration. Oh, no, we don't have it. We have the OH minus concentration, but we know that doesn't matter which way we write it. The OH minus concentration times the H3O plus concentration is equal to 1 times 10 to the minus 14, because that's where we get our pH scale from. So if this is 0.12 and I want the H3O plus, I'm going to go, and I'm going very quickly now because I'm going to run out of time. I'm going to 1 to the minus 14 divided by 0.12, and we get 8.33. That's fine. Okay, so this is 8.33 times 10 to the minus 14. This was the trick because now I can go, well, pH is the negative log, okay, of the H2O plus, so it's the negative log of 8.33 times 10 to the minus 14, and that I absolutely can't do negative log. Please don't forget the negative, otherwise you're going to get a negative answer at the end, and we can't have negatives. Oh, look at that, 13.08. I'm happy with that answer. I had a large amount of base left over at the end, okay? So the fact that I've got an answer that's on the base side of the scale, above 7, not a problem. Okay, it's probably a little high for me, but we always assume 100% ionization. Okay.
Wrap up.
I got to say goodbye now, but it's okay. We have 2 more shows, so keep sending your questions, Wednesday and Thursday, and I'll see you next time.
All right, guys, that does wrap up the last segment of the show. Big shout out to Selo Kumane, who said he enjoyed the show. I hope you guys all enjoyed it as much. Calvin asked what's the best way to study physics, and I always say this, you have to practice, practice, practice. That's the only way you're going to master it. For now, it's goodbye and love from Tracy and I. Bye-bye, guys.